This video is going to introduce you to binary inorganic nomenclature of a very specific kind. So here we have two elements in a compound. Again, one's a cation, one's an anion. And we're going to be given a name to write the formula for it, and we're going to be given a formula so we can determine its name. But here the cations can have a variable charge, which means that any one cation can have more than one kind of charge. It's not the same all the time. So we have to be specific. This applies directly to atoms that come from this part of the periodic table, which includes the transition metals, the metals underneath the metalloids, the lanthanides, and the actinides. So let's move from a formula to a name, shall we? Fe2O3 and FeO. These are two examples that are really good to compare to each other for this kind. If I was just going to use cation and anion names, they'd both appear to be iron oxide. However, iron oxide as a name cannot be used to describe two entirely different compounds, so this can't be right. Let's look into this a little bit more. So oxide, or oxygen here, has a charge of -2, and that's true in both cases. So the charge of iron has to be different in each compound. And since the compound itself is neutral, and we know the charge of oxygen, we can determine the charge of iron. So let's do that in the case of Fe2O3, where I have two iron atoms, each with some charge. I don't know what it is, so I'm going to call it X. And that's being added to three oxygen atoms. Each has a -2 charge, and the whole thing has to add up to 0 because it's neutral. So if I just sort of rewrite the math here, 2x plus 3 times -2 equals 3. Solving for x, that equals 0. 2x plus 3 times -2 equals 0. X equals 3. That means that the name of the compound is iron 3 oxide. Here 3 represents the charge of the iron atom, not the number of atoms present. Let's try it again with FeO. So I've got one iron atom being added to one oxygen atom with a -2 charge, and the whole thing has to add up to 0 because it's neutral. So if I rewrite it, x plus 1 minus 2 equals 0, x equals 2. That means that the name of the compound is iron 2 oxide. So let's go from a formula to a name with Fe2O3 and just sort of pay attention to the steps. So we have to give the name of the cation, iron. We have to give the charge of the cation with a Roman numeral, +3. And we have to give the name of the anion with an IDE suffix, so that is oxide. So that means the name is iron 3 oxide, and here 3 represents the charge of the iron atom. Let's do that again with PbCl4, a different example. Here I've got a chlorine atom that has a -1 charge, and there are 4 of them, and only one Pb. That means that the charge of Pb must be +4. So my name must be lead 4 chloride. And here, the +4 corresponds to the charge of lead. Now let's go from a name to a formula. So tungsten 4 oxide, let's get the formula for that. The steps are, give the symbol of the cation, the Roman numeral is going to give us the charge, give the symbol of the anion, and use subscripts to balance if needed. So I've got W with a +4 charge and oxygen with a -2 charge. I need 2 oxygens to balance out that one tungsten. So that means WO2 is my formula. Now let's try some of these out. Fe3N2, AuCl4, manganese 4 oxide, and tantalum 2 bromide. If you go through and do each one of these, you should come up with iron 2 nitride, gold 4 chloride, MnO2, and TaBr2. These can be a little bit tricky. I encourage you to find as many examples as you can find and work as many problems as you can work. The more you do this, the better you'll get. Best of luck.